What's up, guys? It's Monday, May 11th. We're going to do part 2 for 11.3 today. Like I kind of mentioned before, 11.3 and this entire chapter in general is pretty difficult. All right, but we are going to be simplifying rational expressions still. So, what you guys did last week was you simplified rational expressions that were kind of already factored for you. Now today we have to factor these expressions before we can simplify them. All right, so again, it's pretty difficult. So what I want to do first is just review factoring because we're going to have to factor and then we're going to have to find excluded values and then we're going to have to simplify. Okay, so that's actually your learning target today is I can factor, then find excluded values and then simplify rational expressions. Okay. So there's kind of three things that we're gonna be doing today. All right, so let's review chapter 7, which was factoring. Let's look at something like this in 7.6. In order to factor something like this polynomial, we're trying to find the greatest common factor between these two terms, okay? And that greatest common factor would be 2. All right, so what we did was we factored out a 2. We factored out a 2 right here. And then we were left with x squared plus 9 inside of the parentheses. All right, so that's one example of what we're going to have to do. Here's another. Between 15y cubed and 10y squared, what's our greatest common factor? It would be 5y squared. Okay, so when we factored that out, we were left with 5y squared on the outside, and then what's left after dividing by that greatest common factor, which would be 3y plus 2. All right, that's something we need to know for today's lesson for sure. Let's look at another factoring example from 7.7, where we have a trinomial with nothing in front of the first term. So like x squared plus 10x plus 16, for example. Here's what we did. We tried to figure out, so we're still working with this stuff. We tried to figure out what multiplies to 16 and adds to 10, and that was 8 and 2. All right, so what they do, they go through all this stuff, but what we did at the end was we actually wrote two binomials, x plus 2, x plus 8, all right, from those factors, from the 8 and the 2 that we found for factors. So we need to know that, all right? And then the last thing I want to look at is special products, all right? So not this one, right here. Okay, so these are special binomials that we talked about, all right, where each term has a perfect square. All right, so what we did with that was, for example, x squared minus 25, because they both have perfect squares, we can use the difference of two squares pattern, it's called, okay, where we just make two binomials, one with a plus, one with a minus, all right? So we take the square roots of each term and we make two binomials out of them, all right? So for example, x plus 5, x minus 5. This next one, the square root of 64 is 8, and the square root of y squared is just y. So what we're going to do is say 8 plus y, 8 minus y. All right. Last one would be 2z plus 1, 2z minus 1. All right. So that's the last thing you're going to have to know for this new lesson that we're going to do today. All right. So we have to know how to factor in order to be successful today. So let's get back into it. And let's try this. Okay, so 11.3, we're going to do part 2, where again, we have to factor first before we simplify. All right, so what I want to do first is I want to make up my own example. I don't want us to look at these yet because I'm going to cross them out. Don't even look at these yet. Because again, Big Ideas kind of asks you to do something that they don't show you, which I kind of never understand, but I'm going to show you now. So I'm going to make up my own example of 2x cubed plus 6x squared over, we're going to do 8x plus 24. All right, so I do want us to pay attention to the instructions still. Okay, so what are they asking us to do exactly? This is what the instructions will say today. All right, so simplify each rational expression if possible and state the excluded value. So it's kind of the same instructions as last week, but the difference is these expressions we're going to be given, they're not factored yet. All right. Last week, everything we did, it was already factored for you, and you just simplified it, and you found the excluded value. All right. So what I want to remind you is this. This is your learning target. Your learning target is that we're going to factor first. Okay. So I can factor, and then we're going to find the excluded values, and last, we're going to simplify. All right. So we're doing those three things. So let's go back to this example. All right, so we're going to follow those instructions. We're going to factor first. All right, so what I do when I factor is this. I'm going to look at this top expression first, and I'm going to factor it. Okay, so we're going to go step by step. And we're going to factor this top expression. We're going to say that this is really equal to, what's the greatest common factor between 2x to the third and 6x squared? The greatest common factor would be 2x to the second power. Okay. And then I'm going to leave what's left in the parentheses is going to be after I divide by 2x squared, after I divide this by 2x squared, what's left? 2x cubed divided by 2x squared, there's only an x left. And 6x squared divided by 2x squared would just be 3. All right, so I factored the numerator. I'm going to do the same thing with the denominator now. All right, so we need to factor this. So what's the greatest common factor between 8x and 24? It would be 8. What's left inside the parentheses is x plus 3. Okay? Now, right now, after I factor and before I simplify, I'm going to find my excluded value. Remember, the excluded value is the number that would make the denominator equal 0. All right, so since this 8 doesn't have an x next to it, I'm not really going to worry about it. I'm looking at this expression that does have a variable. So what would make this expression equal 0? -3 is my excluded value in this problem. All right, so this is part of my answer. Okay, so I always want to find my excluded value after I factor but before I simplify. All right, so now's the part where I'm going to simplify. Okay, if you guys remember from last week, I said we can't simplify anything that's inside of parentheses unless two expressions in the numerator and the denominator say the exact same thing, which is actually what we have here. Since I have an x plus 3 on the top and bottom in the numerator and denominator, I can simplify and I could just get rid of them. All right, I can cancel them out because this divided by this is 1. Think about that. Okay, now I'm looking on the outside and I always start with my numbers. I always start with my coefficients or my constants. 2 over 8. 2 over 8, that's really 1/4. Okay, and now I'm going to look at my variable. And technically, I only have a variable on the top. So x squared, there's nothing down here to simplify x squared with or cancel it out. Okay, so that just kind of remains on the top. So, as I always say, do we really need a 1 there? We don't. So our answer would look like this. Our answer would look like this. X squared over 4 is our simplified answer. All right, with our excluded value being -3. Okay, so that's one of your examples. Again, it is complicated. This is difficult to teach virtually for sure, but that's kind of what we're doing today. All right, so when you have like a binomial like this, you want to see what can we factor out. Okay, what can we factor out? That's what we're looking at. All right, now we're going to do the examples from the book. Okay, so what I want to just point out right away is example A. isn't something you're going to be tested on. All right, I'm not going to take a benchmark on questions like this, but it's kind of good to know how to simplify expressions like this. Okay, so if you remember, back to the factoring, when we saw something like this, 1 minus z squared, technically 1 and z squared both have a perfect square. Okay, so what we can do is use the difference of two squares pattern, like we talked about before, and we can write two binomials, 1 minus z and 1 plus z. All right, so we factored now. So right now I'm going to find the excluded value. Okay, so I'm going to look at the denominator, z minus 1, and I'm going to say my excluded value, I'm going to say this now, after I factored, I'm going to say my excluded value is going to be positive 1, because 1 minus 1 is 0. All right, now we're going to simplify this. Now again, this is a confusing example. All right, so we're going to look at what the book does. What we want to do is, I see this on the top, these two binomials, and I see a z minus 1 on the bottom. These look out of order to me, right? They're not in standard form. Usually the variable comes first. So what they do is they kind of rewrite the first binomial with the z coming first, and they factor out a negative 1 because they want this, which would have been negative z plus 1, they want that to look like the denominator so they can cancel it out. All right, so they rewrote it and they factored out a negative 1 or a negative sign to make it z minus 1 so that they could cancel it with the bottom. All right, so that's what they're going to do next, is they're going to cancel out the common factor. All right, so all we're left with is a negative sign and then this 1 plus z, which we're going to rewrite that as z plus 1, right? And then they kind of distribute the negative sign back in to make it negative z minus 1. All right, so, and then there's the excluded value that we talked about before. All right, again, very, very confusing example, but again, you're not going to really be tested on it. You will have to do a couple problems in your practice with it, but I wouldn't worry about things like this too much. All right, let's look at example B more so. All right, so they kind of do some of the work for you. They factor right away. All right, so how did they factor exactly? Let's look at that. So if we look at this top trinomial, remember, how do we factor trinomials? We try and figure out what would multiply to equal this final number, and then what would add to equal the middle coefficient, which would be 1 here. And those answers would be positive 4 and negative 3. So that's where they're getting these two binomials. They made these two binomials from factoring like we have in the past. All right, now they're going to do that same exact thing with the bottom trinomial. So this time it's negative 20, and negative 1, which would be negative 5 and positive 4. That's where they're getting c plus 4, c minus 5. Okay, so right now, this is when I would find my excluded value. All right, the book does not show that, but this is when I would find my excluded value, okay, after I factor, before I simplify. All right, so what's going to make c plus 4 equal 0? Negative 4 would. What's going to make c minus 5 equal 0? Positive 5 would. All right, so these are my excluded values. Now we're going to simplify. All right, so we have a c plus 4 in the numerator and in the denominator. So what they're doing is they're canceling those out. Okay, and we're going to be left with c minus 3 on the top and c minus 5 on the bottom. And that's going to be our answer. So this is your simplified answer here. And again, here's your excluded values that we already found here. Okay, so I'm going to emphasize this one last time. We're gonna factor the numerator and the denominator. Then we're going to find excluded values. Then we're going to simplify at the end. All right, so let's look at a couple extra examples and then we'll be done. You guys can try this yourselves. All right, so I'm going to show you A, but remember it's not very important. We're not going to be tested on it. All right, but I do want to show it to you. All right, so I see d squared minus 4. That's a special binomial. So I'm going to say d plus 2. I'm taking the square roots, remember? D minus 2. Now here's what I'm going to do right away. See this 2 minus d? It's out of order. It's not in standard form. I'm going to rewrite it as negative d plus 2. And I'm going to put it in parentheses because technically anything with a subtraction or addition sign in between it should be viewed as if it were in parentheses. All right. So here's my goal. I want to try and simplify, right? So I want this to kind of say one of these two things, d plus 2 or d minus 2. So like the book did before, we're going to factor out a negative sign. All right. But real quick, let's state the excluded value. All right. So what makes this equal 0? Positive 2 would. So excluded value here would be 2, part of our answer. And then again, I'm going to do this. I'm going to factor out a negative 1. So I'm actually going to erase this right now. I'm going to erase this negative sign. I'm going to erase this plus. I'm going to change everything to its opposite. I'm going to take the negative sign out, and I'm going to make this d minus 2. Okay? So now I can simplify. And I can cross these out and be left with d plus 2 on the top. So in the numerator, d plus 2. And on the bottom, a negative 1, which technically I could divide and make it negative d minus 2 as our final simplified answer here. Okay? So again, confusing. Not too important to know, but I did want to show it to you. Okay, so I'm going to cross this out and focus more on the second example. All right, so let's look at this bottom example quick. S squared minus S minus 6. So I'm going to factor that right now. All right, so I'm going to try and figure out what multiplies to negative 6, adds to negative 1. That would be negative 3 and positive 2. So I'm going to change this numerator to S minus 3. And S plus 2. Okay, I'm going to factor now the bottom, the denominator. Negative 18, I'm trying to figure out what multiplies to negative 18 and adds to negative 7, which would be, this is negative 18, so negative 9 and positive 2. All right, so I'm going to say S minus 9 and S plus 2. Okay, now remember, I just factored. Here's our fraction bar. I just factored. I have to find excluded values now. All right, so my excluded values are what's going to make the denominator equal 0. So S minus 9, positive 9 would make that 0. S plus 2, negative 2 would make that 0. So here's my excluded values. And now I'm going to simplify. All right, I have S plus 2 in parentheses on the top and bottom. We can cross those out. And I am left with my simplified answer, which is just S minus 3 on the top in the numerator and S minus 9 on the bottom in the denominator. All right, so that's it. All right, it's difficult, like I said, to kind of teach virtually, and I do understand that it's difficult to learn virtually as well, but hopefully that made somewhat of sense to you. You guys are going to go into big ideas now and try this practice. It's 5 problems based upon what we just talked about. If you have questions, email me, please, or ask in the discussion thread. Otherwise, I'll talk to you guys tomorrow.